for 1 function, no two elements, suppose this is x1 and this is x2, and x1 comma x2 belongs to the domain. Okay, for simplicity we are taking this set as domain and this set is codomain. This is function f. So x1 and x2 are two elements of the domain. We are not telling that these two are different element or same element. We are just taking two elements and we are applying f on them, the function. This is fx1 and this is fx2. Now we will equate fx1 equal to fx2. Suppose this is fx1 and this is fx2. So we are assuming first that this fx1 and fx2 are both same. That means this is fx1 as well as this is fx2. These two are not different. These are same. So we assume or let fx1 equal to fx2. So at first we are taking two elements from the domain. x1 and x2 belongs to domain. Okay, I am writing domain. We have taken domain as a. So x1 and x2 belongs to a, and after that we let or assumed that fx1 equal to fx2. That means these two elements x1 and x2 has same image. That means fx1 equal to fx2. This x1 equal to x2 has same image. So from this we will prove that x1 equal to x2. That means whenever the images are same, fx1 equal to fx2, the f image is same, then those element from domain should be same. That means each and every element of the domain has unique image. Okay, and this is one way, and another way is let x1 comma x2 belongs to a and x1 not equal to x2, and also let that x1 is not equal to x2. That means these x1 x2 are two different element of the domain. That should imply that fx1 equal to fx2. This is not equal to. So x1 x2 are different element, then their images should be different, and if x1 equal to x2, that should imply fx1 equal to fx2. Or actually in reality we assume first that we don't assume anything about x1 and x2, then we'll let fx1 to be equal to fx2, and then we prove that the opposite part, that x1 equal to x2. This is one case and this is second way. So this was first way and this was second way. This was the first way, this was the. So these are two ways to prove a function 1 1. Okay, now take an example. Suppose fx is equal to 2x plus 5. Now we are taking two arbitrary elements from the set of domain. So let x belongs to R, the set of real number. Okay, so take two element x1 and x2. For this example, we will first let assume that fx1 equal to fx2. So if fx1 equal to fx2, what does it mean? It means that 2x1 plus 5 equal to 2x2 plus 5. This means that 2x1 equal to 2x2. 5 cancelled, and again 2 cancelled, so x1 equal to x2. So we have assumed that fx1 equal to fx2. That means x1 and x2 has same image, and eventually we have proved that this implies that x1 equal to x2. That means whenever two elements are same, their images are also same. That means this implies f is 1 function. Okay, now take another example, fx equal to x square plus 1. Again we are taking two different elements. Suppose x1 comma x2 belongs to R, so x belongs to R. Now fx1 equal to fx2. This implies that fx1 means fx1 is what? x1 whole square plus 1, and fx2 is what? x2 whole square plus 1. So I don't have to tell this. I think this will is easy to, I mean, this is clear to you. What is fx1 and what is fx2? So that means x1 whole square plus 1 equal to x2 whole square plus 1. This implies that x1 whole square equal to x2 whole square. So now this don't give only one solution, that x1 equal to x2. This gives that x1 equal to plus minus x2, or x2 equal to plus minus x1. So that means for x1 equal to x2, fx1 equal to fx2, and also x1 equal to minus x2, fx1 equal to fx2. That means what? For two different value of x1, that is what? One is x1 and another is minus x1. One is x1 only and another is minus x1. fx1 is equal to fx minus fx1. So basically we have taken x2 as minus x1, or we can take x1 as minus x2, whatever. So for different values of x1, i.e. x1 and minus x1, fx1 and minus fx1 is both same, that is equal to x1 whole square plus 1. So that means f is not a 1 function, that is f is many one function. many one function. Clear?